transform and a Laplace transform for solving heat equation, wave equation. Or you can say that the applications of Fourier transform and Laplace transform for solving partial differential equations. So I will start with the example or question. You have to solve. A question is we have curly u by curly t, that is 2 times curly u by curly x square, and the conditions are u0t is 0 and u x of 0 is equal to e raised to power minus x, x is positive, and u xt is bounded. This is a very important condition, boundedness. Always remember u is a function of a variable x and t. You have to solve this partial differential equation. This is the heat equation. If you compare this equation with yesterday's standard equation, you will see that there was a 1 over a c square, I think. No, there was a c square only. So accordingly, in place of c square, we have 2 here. So the value of a constant in c square is 2 in our equation. This condition is clear. This is a part of the boundary condition. This is at t is equal to 0. Then that means this is initial condition, and u xt bounded. It means the value of u xt approaches to 0 as x approaches to infinity. You can use this condition whenever it is required. So let us solve. As we know that this condition is given, then if this condition is given, then you need to apply Fourier sine transform. Because if boundary condition is given to us, then we can apply Fourier sine transform. So you can write down even since u u0t is given. So taking a Fourier sine transform to both sides of this partial differential equation, and you can also name this a partial differential equation. So I am going to name this as equation number 1. So name it as equation number 1. So since what is given to us, u0t is equal to 0 is given. So taking the infinite Fourier sine transform, what we shall get, you need to integrate it within the limits 0 to infinity, that is del u by del t into sine of, you can take the parameter. The parameter p can be taken in place of s, but I am taking the s, x, d, x, and that is 2 times integral 0 to infinity. That is a del square u by del x square sine sx into dx. So this is the important step by taking the Fourier sine transform. Now in the next step, this is very common step because this is the integration with respect to x, but this is the derivative with respect to t. It is very important step. You can write this like dgt of integral 0 to infinity u xt sine of sx dx. You can always take an independent variable out, like it will become dgt, and on the right hand side we will integrate it by parts because this is the integration with respect to x, and this is the integration with respect to x, and this is also a function of x, and this is also a function of x. And एक मिनट रुक जाइए, बोर्ड में थोड़ा सा दिक्कत आ रही है. So So you can integrate it by parts, taking it as first function. This is a second function. Problem is there. The first function can be written because it is the double order derivative term, and can be written like this. You can take this as first function. That will be more better. Expected problem is occurring, and you can take this as a second function. So first function can be taken as it is, and the first function can be written as, that is a sine of sx into its integration. The integration will be del u by del x, because it is already the derivative term. So del u by del x within the limits 0 to infinity minus 0 to infinity derivative of sine sx, that will be s cos sx into its integration del u by del x dx. Now, if you see, we know that what is this on the left hand side, this one, this bracket, it is the Fourier transform of function u xt. And remember the Fourier transform of a function, we remember the definition. And by definition, the Fourier transform of a function of x is always a function of Fourier transform of a function of x is always a function of a parameter s. And on the same pattern, the Fourier transform of uxt will always be a function of a parameter u s t. X will change to s, and in short, it can be written like this, that is US bar. This is the meaning of US bar. This is the Fourier transform of UXT. And if you see, this is UXT, it's a Fourier transform. So that will be equal to UDT of US bar. Its value is taken from this step, and on the right hand side we can substitute the values. And if you see, because and u del u by del x is there, this is the derivative term, and del u by del x, as we know, uxt is bounded. You see upward, uxt is bounded. It means uxt approaches to 0 as x approaches to infinity. If this will approach to 0, it means its derivative will also approach to 0 as x approaches to infinity. So accordingly, for the upper limit, the value of this term will come out to be a 0 value. And on the other hand side, the sign of 0 will also be a 0. So ultimately, here you will get s outside, and you can integrate again. And if you integrate by taking this as a first function, volume is created. So you can take this as first function, and this as a second function. So you can write down first function as it is, cos of sx, and integral of a second, that will come out to be u with the limits of 0 to infinity, and integral 0 to infinity, and you will be able to write down the derivative of cos, and the derivative of cos first will be equal to minus s into sine sx into u into dx, and the limits are 0 to infinity. So ultimately, you can substitute the values, and you can simplify the terms like this. Now, what it come out to be, that is the 2 times, this will be minus s is also there. You can take s common. Some problem is here. बार बार आई जा रही है, इसको बाद में चलो मैं रेक्टिफाई कर लूँगा, उन लोग क्वेश्चन कंप्लीट कर लेते हैं. Minus 2s into, now you see, because the u function, and the u function is what? Here is it u function. U is a function of x and t. And what is the uxt? Uxt is bounded, and uxt bounded mean it approaches to 0 as x approaches to infinity. Ultimately, for the upper limit infinity, the value will come out to be 0, and for lower limit 0, cos 0 will come out to be 1, and u, the value of u at x equal to 0, that will be u0t. It can be written like this, that is u of 0, and this will be written as minus and minus plus. S can be taken out, 0 to infinity, u is as it is, and that is the sine of sx dx. This is the u function, and we know that the value of u0t is also 0 if you see the above conditions. That is, the u of 0t is equal to 0. That is the first condition, only condition. So you can use this as a 0, and ultimately this is s and this is s. So that will be minus 2s square. And what is this? This is the Fourier transform of u function. This one. This is the Fourier transform of the function u. And what is this? Fourier sine transform. So ultimately, what was written? That was the Fourier sine transform, and it is written as u as bar. So it can be taken to the left hand side, du s bar upon dt upon dt plus 2s square us bar is equal to 0. Now you have to solve this equation, and this equation can be solved by separation of variable method. That will be d us bar upon us bar. So us bar will be there, and on the other hand side it can be written like this. That will be minus 2s square into t. So you can integrate it now to s square dt. This is minus 2s square dt. So ultimately you will integrate it, but it come out to be that is log of us bar is equal to minus 2s square into t. After integrating it, that will be minus 2s square into t. Now, and what will be the other value? That will be written as plus log of c. This is the constant of integration. So that can be written as log us bar over c minus 2s square into t. This is just a simple simplification of solving the equation. Minus 2s square c, that is us bar over c. C is a constant. If we remove log, it will write the exponential factor on the right hand side. So ultimately what will come out to be us square, and clearly, sorry, us bar, and us bar is clearly a function of parameter s and t. So it can be written in that way, that us bar is a function of parameter us bar is a function of parameter s and t, and that will be equal to c time that will be equal to c time e raised to the minus 2s square t. Now you have to, this is the solution of the question, namely the question A. This is the solution, but this is the solution after taking Fourier transform. Now we have to use inverse formula to find out the exact solution. So taking the inversion formula, what we should have, inversion sign formula we have to apply, that will be 0 to infinity, and this will come out to be, what you have to do, you just need to apply the inversion formula, and by inversion formula we have to find out the solution. But before this, we need to use the third condition also, and your third condition was That was u of x0 is equal to e raised to power minus x. It is given to us. You can also take its Fourier transform, Fourier sine transform, that is u x0 sine of, let me finish this question, then I will rectify this problem. So sine sx dx, and on the right hand side e raised to power minus x sine sx dx within the limits 0 to infinity. And what will come out to be us bar function of s and 0, and on the other hand side you need to integrate, and the formula is e raised to power ax sine dx, and by that formula it will come out to e power minus x 1 plus s square minus sine sx minus s power sx given the limits 0 to infinity. And if you solve this, solve these limits, and it will come out to be s upon, after substituting the limits, we come out to s upon 1 plus s square. So remember, this is the value from the third condition, and we shall use the value. Now, come back to the question. If we just see, this is the value of u s bar s0, and that come out to be s upon 1 plus s square. Now, if we use this, will the, we have to find out, or we have to apply the condition. We have to use this condition star for finding out the value of the constant c. And whatever your constant c, then you have integrated. So you just see your constant of integration is this one, that is the c, and you need to find out this c. So use t equal to 0, put t is equal to 0 in equation a, we will get u as 0 here, that is the c e raised to power minus of 0, and ultimately this come out to be, this come out to be the value, that is s over 1 plus s square. So this is your value of constant c. So this condition is helpful for finding out the values of constant of integration. Now, finally, we shall take an inversion formula or an inverse formula. But before this, let us use this value of c, and you can write down the required expression. The expression is us bar, that is a function of s and t, s over 1 plus s square into e raised to power minus 2 s square into t. This is the solution now. Not, this is not the solution. This is the Fourier sine transform after substituting the value of the constant. But because we want to solve the equation, and the equation is here 1, in which u is the dependent variable. It means we need to find out the value of u, and clearly u will be a function of x and t, but here is u s bar. This is a function of s and t. So we just take its inverse Fourier sine transform and get the value of u x t. So therefore, taking an inverse Fourier sine transform, that will come, that will give u x t, that is 2 upon 5 integration 0 to infinity, that is s over 1 plus s square e raised to power minus 2 s square t into sine of s x ds. So this is your value of u. And if you be able to find out the integration of this, you will get the exact value of the solution. but it is not easy because there are three functions. First function is s upon 1 plus s square. Second function is exponential function in s. Third function is a trigonometric function. So I don't think this is feasible for us in traditional methods to find out the exact value of the integrand. So you can leave the question here that this is your required solution. In transformed method, you can write down the solution in the integral form also. So this is your required solution of the given differential equation, that is the integration. So I thank you here. Thank you very much. And technical problem is occurring, that is connection to the device was unexpected terminated. I will rectify this problem.